Good morning students. Today we are going to discuss few topic from chapter 6, and the chapter 6 is your work, energy and power. The topic which we are going to discuss is your conservative and non-conservative forces. Now let me read out what we have written. A force is said to be conservative force if the work done by it in displacing the particle from one point to another point is independent of the path followed by the particle, but depends only on initial and final position of the particle. Let me repeat once again. A force is said to be conservative force if the work done by it in displacing the particle from one point to another point is independent of the path followed by the particle, but depends on initial and final position of the particle. So it only depends on initial and final position of the particle. The general figure is like this. Suppose you have to reach from A to B. So you can move from this path A to B, or from this path A to B. And also you can move considering this path from A to B, and also in this way also you can reach. So whatever be the path followed, but if the destination is correct, then possibly it is your conservative force. Suppose let me specify this one, path 1. This is your path 2. This is your path 1. This is your path 2. You see, you can reach from A to B via this path. You can reach from A to B via this path. You can reach from A to B via this path. You can reach from A to B via this path. So whatever be the path followed, but if the destination is same, then the force is said to be conservative. So let me to repeat once again this definition. A force is said to be conservative force if the work done by it in displacing the particle from one point to another point is independent of the path followed by the particle, but depends only on initial and final position of the particle. So you are displacing the particle from A to B via the path 1 or path 2, or via path 1 or path 2 in second figure. But if the destination is same, then the work done by the force is, or the force is said to be conservative force by which we have done the work to move the particle from A to B. So it is independent of the path followed, but it depends on the initial and final position. Now there are few examples of conservative force: gravitational force, electrostatic force. These are the conservative force. In figure 1, we are trying to move a particle of mass m against the gravitational force from A to B. So let me read out. Work done to move the mass m from A to B. In figure 1, we have given a straight path from A to B. But in figure 2, we have given a zigzag path. The particle have to move, reach from capital A to small a, then A to B, then B to C, then C to D, D to E, E to F, and F to B. Now in figure 1, the work done against the gravitational force is your W equal to mgh, if m is the mass of the particle and h is the height of the position from where to where we have to take the particle of mass m. Now in figure 2, you see work done against the gravitational force. Gravity acts vertically downward. There is no gravitational force in horizontal direction. So if you consider the path AB, DC, EF, then these are the horizontal direction, and there is no gravitational force. Rather, the gravitational force is in vertical direction. That is your capital A to small a, small b to small c, small d to small e, small f to b. So no work is done if you want to move the particle against the gravitational force A to B, small a to small b, d to c, e to f. So if you sum up this small vertical distance, that is capital A to small b to small c, small f to capital B, then you will see the total length is nothing but is your h. Let me to repeat. capital A to small a, small b to small c, then small d to small e, small f to small b. If you add up this vertical distance, sum is nothing but the distance small h. So the total work done from figure B is figure 2 also, W equal to mgh. So you see the work done remains same in both the cases because it depends on the initial and final position is same, A and B, but it is independent of the path followed. That's why gravitational force is a conservative force. Here we have performed work against the gravitational force. That's why we have written in down in under the note, work done against gravitational force, and the gravitational force acts vertically downward. So this is your conservative force, and the definition is like this: if the work done by the force it depends on the endpoints rather than on the path followed, then the force is said to be conservative force. Let me to read out this one once again. A force is said to be conservative force if the work done by it in displacing the particle from one point to another point is independent of the path followed by the particle but depends only on initial and final position of the particle. Now next one is your non-conservative force. It is just the reverse of this one. A force is said to be non-conservative force if the work done by or against the force in moving the mass, you can say in moving the mass from one position to another position depends on the path followed by the body between these two positions. Let me repeat. A force is said to be non-conservative force if the work done by or against the force in moving the mass from one position to another position depends on the path followed by the body between these two positions. So it depends on the path followed rather than on the endpoints. For example, force of friction, viscous force is your non-conservative force. Let me to repeat the definition once again. A force is said to be non-conservative force if the work done by or against the force in moving the mass from one position to another position depends on the path followed by the body between these two positions. Now potential energy, already you know, the energy possessed by a body by virtue of its position or configuration is called potential energy. Now here we are trying to consider this one figure to define gravitational potential energy. So let me read out once again what is gravitational potential energy. Gravitational potential energy is the energy possessed by a body by virtue of its position in the gravitational field of Earth. Okay, at different position, different energy is there because different amount of work you have to do against the gravitational force. So you see in this figure two forces, one is your F vector, another one is your F dash vector, and 2 points capital A and capital B. So you see gravitational force acts downward. So capital F vector is your applied force. You are moving the mass small m from A to B against the gravitational force, that is F dash vector. Now here we have written F vector equal to applied force and F dash vector equal to gravitational force. So work done by the applied force, you are moving the mass from A to B, so displacement and the force is in same direction, so it's your cos 0 degree as per the definition of the work done dot product, that is your FH. And gravitational force acts vertically downward and you are moving the mass from A to B. So if you consider the gravitational force, then that W dash vector equal to F dash vector dot H. So F dash H cos 180 degree, that is your 180 degree angle. So cos 180 is your minus 1. So W dash equal to F dash H with the negative sign. But F and F dash is nothing but the weight of the object, the minimum force, that is your equal to mg. So you can say that if you substitute this value F and F dash in 1 and 2, you will get W equal to minus W dash. So work done by the applied force and work done by the gravitational force. So try to check out this topic and try to find out your doubts. So if you have any doubt, you can ask and try to understand and always compare the topic with the reference book. I think all of you have your reference book. Thank you.